In the previous video, we were discussed about elastic collision in one dimension, and we find the velocity of two bodies A and B after collision. Then we were discussed about the different cases, and the first case was if two bodies A and B have equal masses, means m1 equals to m2 equals to m. Then from sixth number equation, v1 comes to be equals to u. The velocity of body A after collision must be equals to the velocity of body B before collision. And from equation number 7, when we put m1 equals to m2 equals to m, then we get v2 equals to, at the place of m2 and m1 we have to put m, so m minus m upon m plus m into u2 plus 2m upon m plus m, 2m, 2m upon 2m into u. So this again, this term becomes 0, m minus 1 0. So we get v2 equals to 2m and 2m cancel 0. So v2 equals to u. Here there was v1 equals to u. So after collision, the velocity of body B must be equal to the velocity of body A before the collision. So v2 equals to u1 means after collision. After collision, velocity of body B is equal to the velocity of body A before collision. Before collision. So we conclude that after collision, both the body interchanges their velocities. After collision, v1 was equals to u2, and after collision, v2 was equals to u. So this was the first case when the two masses are of equal magnitude, m1 equals to m2 equals to m. Then we get v1 equals to u2 and v2 equals to u. After collision, velocity of body A must be equal to the velocity of body B before collision, and after collision, velocity of body B is equal to the velocity of body A before collision. Now we discuss another case. That is case number 2. Case 2. When a body collides This is the case number 2. When a body collides against a stationary body. When a body collides against a stationary body, of equal mass, means two bodies having their masses equal, m1 equals to m2 equals to m, and the velocity of body B is 0, means body B is at rest. So u2 equals to 0. Another body is stationary, means another body is at rest. So from equation number 6, we put the value of m1 equals to m2 equals to m and u2 equals to 0. So v1 equals to m minus m upon m plus m 2m into u1 plus 2m upon 2m into 0, because another body B2, the body B is at rest. So from here we get m minus m equals to 0, and this also 0, means velocity of body A after collision comes to rest. So if a body of mass m1, if a body of mass m moving with velocity u1 collide with another body of same mass, but the another body is at rest, means u2 equals to 0, then after collision the body A comes to rest. So we conclude that after collision body A comes to rest. After collision body A comes to rest. Now from equation number 7, again we put the value of m1 equals to m2 equals to m and u2 equals to 0. So we get v2 equals to m minus m upon 2m, and u2 we have to take 0 plus 2m upon 2m into u1. So v2 equals to u1. Means after collision body B acquires the velocity of body A. After collision the body B acquires the velocity of body A before collision. V2 equals to U1. After collision, the body which was at rest after collision the body which was at rest, body B was at rest. So body B which was at rest after collision acquires the velocity of body A, and the body which was moving initially, the body which was moving initially after collision comes to rest. So body A comes to rest after collision and body B started moving with the velocity u1. u1 was the velocity of body A before collision. So this is the second case. Now we discuss the case number 3. Third case. Case 3. When a light body collides against a massive stationary body. When a light body collides against a massive stationary body, means the body which is in motion before collision have less mass and the body which is at rest having more mass. It means M1 is much less than M2. M1 is much less than M2. And lighter body M1 collides against a massive body M2. When a light body collides against a massive stationary body, body B is a stationary, means before collision u2 is 0. The massive body means body B is at a stationary position. So from equation number 6, M1 is much less than M2. M1 is much less than M2 and the quantity which is much lesser must be ignored. So V1 equals to M1 is much less than M2, so we ignore the M1, so we get V1 equals to minus M2 upon M1 we ignore, so plus M2 minus M2 upon M2 into U1 and plus 2M2 upon M1 is much less, so we ignore the M1, so M2 into U2, U2 is 0, body B is at rest, so M2 cancelled, but this term becomes 0, so we get V1 equals to minus of U1. Means if the stationary body is massive, suppose this is body B and there is another body A, mass of body A is much less than the mass of body B and body A is moving with velocity u1. Then after collision, body A changes its direction of motion. After collision, the body A started moving in opposite direction. V1 equals to minus of u1. V1 equals to minus of u1. Means after collision, the magnitude of the velocity of body A remains same, but it changes the direction of motion. Body A changes the direction of motion. And from equation number 7, V2 equals to M1 is much less, so M1 will be ignored. So M2 upon M2 and U2, the value of U2 is 0 plus 2 M1. M1 will be neglected. M1 will be neglected. So 2 M1. V2 will be approximately. M1 will be neglected. So the mass of M1 is much less. This value will be neglected. This will also be neglected. So much lesser value when divided by the much larger value, we get very small value of velocity, and that will be negligible. That will be around to be 0. So V2 is approximately equals to 0. V1 equals to minus U1. Body A changes the direction of the motion and body B will remain at rest. The body B will remain at rest. V2 is approximately 0 after collision. It will not move because mass body B is massive. It has more masses. So after collision, the velocity of body B will be approximately 0. Now we discuss case number 4. Fourth case, when a massive body collides against a light stationary body. When a massive body collides against a lighter stationary body. This is the case number 4. When a massive body collides against a lighter stationary body, means M2 is much less than M1. When a massive body collides against a lighter stationary body, M1 is much greater than M2 and M2 is much less than M1. M1 means body A. M1 is body A, body of mass A, which is massive, and M2 is much less than. And body B is stationary. When a massive body collides against a lighter stationary body, means U2 equals to 0. U2 equals to 0. In the previous case, U2 was also 0 and again U2 is 0. Only there is change that in the previous case M1 was much less than M2. The body which was moving was lighter. But here the case has been changed. M2 is much less than M1. That is, the body which is moving is massive body. It has more mass. The body which is moving has more mass. And the body which is at rest has less mass. So from equation number 6, M2 is much less than M1. So M2 will be ignored. So V2 equals to minus of M1. We ignore M2. Minus M1 upon M1 into U1. From equation number 6, M2 will be neglected. So M1 upon M1. M1 upon M1 into U1 plus M2 will be neglected. So M2 is much less than M1, but U2 is 0. So this whole term will be 0. So V2 equals to M1 upon M1 into U1. And we get V2 equals to U1. V2 equals to U1 means the body B which was at rest acquires the velocity of body A, acquires the velocity of body A. So the body B which was at rest, body B which was at rest acquires the velocity of body A after collision. After collision, V2 equals to U1. The body B which was at rest started moving in the forward direction with the speed equals to U1. Means body A and B interchanges their velocity. And what about the velocity V2? So from equation number 7, from 7, V2 equals to M2 will be neglected, so minus M1 upon M1, and U2 is 0, so into 0 plus M2 is much less than M1, so we get 2 M1 this was velocity V1. V1 equals to U1. V1 equals to u1 means body this was the expression for v1 when the body collides against a light body u2 was equals to 0 then v1 equals to u1 v1 equals to u1 means after collision the body A has the same velocity which was before the collision v1 equals to u1 after collision body A has the same velocity as before collision means velocity of body A gets unaffected. Velocity of body A gets unaffected. And from equation number 7, we get V2 equals to F2 will be neglected, so minus F1 upon F1 into U2 means 0 plus 2F1 upon F2 will be neglected. So 2F1 upon M1 into U1. M1 cancelled and we get V2 equals to 2U1. V2 equals to 2 times of U1. V2 equals to 2 times of U1 means after collision velocity of body B is equal to twice the velocity of body A before collision. V2 is equals to twice of U1 means after collision velocity of body B is equal to twice the velocity of body A before collision. So from equation number 6 we get V1 equals to U1 means the body A after collision the velocity of body A after collision gets unaffected. After collision, the velocity of body A is equal to the velocity of body A before collision. There is no after collision, but the velocity doesn't get affected. And from 7th number equation, the body which was at rest acquires more velocity, twice the velocity of body A. The body which was at rest acquires the velocity, twice the velocity of body A. Means the body which was at rest before collision started moving with a larger velocity. The body which was at rest before collision started moving with a larger velocity, twice the velocity of body A before collision. So these were the four cases. In the next video we discuss perfectly inelastic collision in one dimension. This was perfectly elastic collision in one dimension.